Okay, now let's look at some examples to see if we can determine what these are based on data, right? We've only talked about generic up to this point. And then we're going to state whether this is two-tailed, right? Remember, two-tailed does not equal. Left-tailed is less than, or right-tailed, which is greater than. All right. Okay. So the Medco pharmaceutical company has just developed a new antibiotic for children. 2% of children taking competing antibiotics experience headaches. A researcher for the Food and Drug Admin wishes to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is what? More than 2%. So if I'm looking at this, the two types of hypotheses that we are going to be looking at are going to be proportion and mean. All right? That's what we're talking about. So if we're going to determine a null hypothesis and an alternative hypothesis, P and P, because if I'm looking at this, this is a proportion that we're talking about. I know it is a proportion that we're talking about because it says 2%. That percentage is going to dictate the proportion. All right? So that's how I know that I'm going to be working in terms of P because of that percentage. All right. Now, what do we know about the null hypothesis no matter what? Always. It's equal, right? Every single time it's equal because it's what we already know. So what is the current data telling us? That we are at 2%. And of course, we're going to change it to a decimal, right? Because we're talking about a proportion. Proportions are decimals. So currently, we're saying 2%. What is the Food and Drug Administration want to know? What are they changing this to? What is the new information they're trying to figure out? If it is more than, right? More than 2%. That's how you set it up. What do you currently know? That's the null. What is the question asking? That's the alternative hypothesis. Boom. That's all there is. Now, what kind of tail is this? Two tail, left tail, or right tail? Right tail, because it's more than. Right-tailed. Because of the greater than symbol. That's all there is to it. Yeah. Don't try to make this harder than what it is, right? We're just setting this up. What your problem tells you, that's what we've got going with it. So I just want to make sure you're comfortable with this notation, and then we're going to be using it a little bit more for the rest of this chapter. All right, let's look at this one. The Blue Book price of a used 3-year-old Chevy Corvette Z06 is $59,083. Grant wonders if the mean price of a used 3-year-old Chevy Corvette Z06 in the Miami metropolitan area is different from $59,083. Okay, so this is talking about a mean. If I have a mean, what symbol, and we're talking about population here, what symbol goes with mean? Mu. Good. So that's a symbol we're going to use here. So I have to figure out an alternative hypothesis, a null hypothesis and an alternative hypothesis. So no matter what, I'm talking about a mean, so I know I'm going to be using mu here. And then what information do we currently have? Yeah, the price of this Corvette is $59,083. What about the alternative hypothesis? What symbol are we using? Is it greater than? Is it less than? Does it just change? Yes. The fact that it says different right here, that tells you it does not equal. That's all that means. So this does not equal 59,083. Are we saying it's more than? No. Are we saying it's less than? No. He just wonders if it's different. So it just doesn't equal the same thing. And so if it does not equal, then what are we going for? Two-tailed. Good. Two-tailed test because it does not equal. That's a does not equal sign. Good. So literally you're just getting the information from the problem. Your null hypothesis is what you already have. You have to look for the fact that, are you talking about a proportion? So you use P. Are you talking about a mean? So you use mu. All right. The third type that we're not really going to talk about, but there is a third type for standard deviation. So if we were doing standard deviation, then you would use sigma for standard deviation. But the two that we're really going to focus on is the proportion and the mean. All right. Because that's what we've been focused on this whole time. Okay, cool. So here's a little summary at the very bottom, which I think is nice. So in other words, structuring this null and alternative hypothesis, first identify the null. Identify the parameter that you're going to be testing. Set it up. Get the status quo of that parameter. That's your null hypothesis. What do we already know? What are we talking about and what do we know about it? Is it a mean? Is it a parameter? Pardon me. Is it a mean? Is it a population? That's what we want to know. Then we want to determine the statement that reflects what we're trying to get. This gives you your alternative. Is it less than? Is it greater than? Is it different? That's what we're trying to say. No matter what, look at what, I'm going to squeeze this in. 0.02, 0.02. 59083, 59083. It's the same numbers here. I'm talking about the mean, still talking about the mean. Talking about a proportion, still talking about a proportion. The null is what I already know. That will always be an equal. The literal only thing that changes is the symbol in the alternative hypothesis. All right? Pretty cool, right? It's not that bad. It's not that bad. Just reading the problem and writing out what it is that you see.